Hello and welcome. Thank you for being here. Thank you for attending my talk, and thank you organizers for inviting me and putting all the hard work to do this conference, especially that it's the first time in the city. I know how stressful it is. So thank you again. We're going to talk about HoloLens today. So I'm going to introduce you to this technology, to this device. But let me first introduce myself. I'm Rafał Legiędź. You can find me on Twitter at Rafek. And I work for a consultancy company based in Kraków, Poland. What I do is for the last 6 months, I'm involved in exploring those AR experiences that you can get with HoloLenses. So I'm talking with different businesses, trying to find ways where we could employ this technology into their businesses. And also I'm a conference organizer. I organize a conference in Krakow for the last 7 years called DevConf. And I try to be a conference speaker as well. So whenever I think I have something interesting to say, I just apply to conferences, and hence I'm here, for example. So we will see and hear several abbreviations during this talk, so I want to make be sure and make clear that everyone is familiar with both. So the first one is VR and the second one is AR. VR stands for virtual reality, and that's basically the experience where the user put a headset on and he or she is being transformed totally into fully synthetic world, which is fully rendered, and the user vision is occluded by the device. So basically the user doesn't have a sense of the real world. He's totally immersed into a virtual one. And the mind is basically tricked into thinking that the real world doesn't exist, that there is only this virtual one. And you can easily see that, for example, while watching those VR prank videos that you can find on YouTube, where there's a player, for example, with a VR headset, and there is the other person standing next to the player and just poking the guy, and the guy with the headset freaks out because there is something coming from like different world, right? Because the mind is very tricked. And the other kind of experience is AR, which stands for augmented reality. And it comes in different forms. The most common one are the applications that run on mobile phones or tablets, where basically whatever the device sees through the lenses is being displayed on the screens, and then the digital content is being overlaid on that screen. And in this case, we can see our real world kind of augmented with digital content. But here, the central word to the user is still this real one. The user still thinks that he is in this real world and only sees like a part of this world through the lenses of the device. Also, we have some kind of other devices like Google Glasses or other similar wearables, where basically we can have some digital content rendered in front of our eyes, but still user knows really well that he is in the real world. So where all those devices are compared to each other in some kind of spectrum. So given that we have this physical world that we live in and that we experience every single day, at least I hope we are, and on the other hand, we have digital reality, like fully digital world. It occurs that there is the whole spectrum of experience that we can get that span between those two realities. So very near the physical reality are where almost all current AR experiences or devices lays. Basically because what I actually mentioned, that the user still thinks that he or she is in this real world, the physical world. He only sees the augmented world through some kind of a screen, so the user is still fully aware of his environment. Some of the devices are a little bit more sophisticated or have some better sensors or better software that runs on it. For example, AR Core from Google or AR Kit from Apple, where the digital content can be blended with physical world in a slightly better way. On the other hand, we have VR experiences, which live all the way on the other side of this spectrum, near digital reality. And that's because those are fully synthetic experiences. So there is no sense of real world there at all. And where are HoloLenses, which I'm going to talk about? So HoloLenses are kind of a very sophisticated AR device, so it still lays near this physical reality, because user is still in this real world, user can perceive the real world, but the whole bunch of sensors that are there inside HoloLens, which I'm going to talk about a little bit later, they deliver possibilities that the developers can create applications that blend the digital content in a really seamless way with the user environment. So the immersion effect for the user is really great, and we'll see that. On the other hand, it's worth to mention what Microsoft is doing actually at the moment, because they, 1 month ago, like 17th of October, they released a bunch of new VR headsets, which are called Windows Mixed Reality headsets. And basically what they did is they released something that is really similar to what we already had, like Oculus Rift or HTC Vive or PSVR. But they employed some kind of, they employed a bit of technology from HoloLenses there, so that those headsets can actually track themselves, track their position in the environment by themselves. Because Oculus Rift and Vive, for example, they need external sensors to track the user movement and location in the real world. And the new headsets, they don't require it, so that it kind of opens new possibilities, and they can give user like more sense of being in the real world. But it's not AR, it's still VR. Anyway, the whole spectrum is called mixed reality. And that's the term that Microsoft is using a lot recently, just after Azure, of course. And it's not a new term. It was, I don't know, it was firstly seen in some kind of paper like 30 years ago, or something like that. But yeah, right now it's a really big thing, and all the experiences that lives between those two extremes are called mixed reality. And what I think Microsoft is trying to do right now is that they're trying to fill that gap and deliver some kind of set of devices, or maybe one ultimate device that would be able to deliver all kind of experiences. Because firstly they released HoloLenses and they released mixed reality headsets like a month ago, and they're really pushing this technology forward. A little word more about those mixed reality headsets, because this is very exciting. So here are HoloLenses, and all of those are mixed reality headsets. And it's not by Microsoft. I mean, HoloLenses are produced by Microsoft, but the headsets are produced by partners, basically like Dell, Asus, Acer, etc. The thing is that it's all powered by Windows 10, and the newest update to Windows 10, called Fall's Creators Update, it comes with the support for mixed reality. So every user that has Windows 10 can use those headsets, and they do not require like a really expensive graphic card, because they can even work with the cheaper versions. And the headsets are way cheaper, maybe not way cheaper, but cheaper than Oculus or Vive. And what's also cool here is that it's not only for gaming. You can basically plug it into your PC and experience your Windows 10 in VR. Basically, your desktop becomes a house, which is called a cliff house, where your applications are on the wall, and you can, for example, get an application from Windows Store and just stick into the wall, like, for example, Netflix app, and just stick it on the wall, like resize to be a big one, and just watch a movie like that, which is kind of cool. And also, we can play games, of course. And the other exciting thing is that, as it's the common platform with HoloLenses, is that we can create, as developers, experiences that are being shared between the two ones. So, well, that's probably the subject for a whole different talk, but basically we could have like a guy with HoloLenses looking at some holograms in augmented reality, and we can have another guy wearing, for example, one of those somewhere far away from us, and it would be displayed as an avatar for this AR guy, and the other guy will see actually the very same thing. So this unlocks really cool scenarios. But let's focus on HoloLenses. So how many of you actually heard about this device before? Well, maybe half of you. So, okay, so it's not a very new device because it was announced in late 2015. Then it was released in early 2016, and the first wave of devices was sent to developers in June 2016. So it's been a while since they are on the market. And actually, there are plenty of companies and developers that embraced this technology, and they started creating all kinds of stuff with it, which I'll show later. And what's that? Basically, it's as I mentioned, very sophisticated AR device. You put it on your head, you fire it up, you run an app, and all of a sudden you see your world with a whole bunch of holograms and some 3D objects that lays around you, or the ones that you can interact with. Also, it's powered with Windows 10, so it's basically a PC that runs Windows 10, some kind of holographic edition of Windows 10, but basically it's a PC. It's untethered, so it's unlike every other headset. You don't have to connect it to your PC, so you can just go wherever you like with that and have your hands free and without the cord. Also, well, the battery life, that's the most common question. It's something between 2 and 3 hours of active use, so it's not very long, but it's sufficient. Anyway, let's focus now on all those internals that allows for all the magic that to happen. So first of all, sensors. There are a whole bunch of sensors there. You might think that it's basically more fancy Kinect that is being connected to user's head, but it has something more than that. Basically, the most important thing, in my opinion, are those 4 environmental scanning cameras or environmental understanding cameras, which basically are for scanning the user environment. So the device gather all the information about where the floors are, ceiling is, walls, chairs, on all the platforms. So it basically reads the user environment and gathers it on the operational system level. Also, there is like a regular RGB camera, HD, mixed reality capture module, ambient light sensor, 4 microphones, which are here, which are basically for getting user voice input. And there are 4 of them because the device has to be sure that the command comes from the actual user and not the guy staying next to the user. The other thing is optics. Those are really fancy glasses because they are optical see-through so that we can still see the world, but they can render some stuff in front of the user eyes in a really convincing way. And each eye is being powered by an HD engine, so it gets roughly 1200 by 700 pixels per eye. But we do not describe those lenses in terms of resolution as we describe regular screens, because all the pixels are already there, I would say, right? Because the real world renders everything. We only need those holographic stuff to render around us. So how we describe resolution in HoloLens is by holographic resolutions, which is basically how many light points, that's how it's called, can be rendered in the given moment. So HoloLenses can render 2.3 million light points in the given moment. And also, instead of DPI, as we have in regular screens, we have holographic density in those lenses, and it's like how many light points per radian can be rendered. In this case, it's 2.5K light points per radian. Anyway, that all means that the resolution is kind of good, the objects you can render are really nice, and well, it looks like you will see on the pictures anyway. The other thing, holographic processing unit. That's the core, I would say. That's the unit that processes all the sensory data. So whatever comes from the sensors goes through this coprocessor, because that's a coprocessor, not the main one, and then after being processed, it's being transferred to the main one. And it's a customly built chipset, especially for HoloLens. And it was produced by Intel, I guess. And you might have heard some rumors on the internet that Intel stopped producing that chipset. And that's kind of sad news, because that puts a question on what's next, right? But Microsoft already announced that they started working on the new version of this chipset. So that's good news. And actually, what they told is that the next version will have some kind of AI chipset also on board. So that led us thinking that the HoloLens V-Next may be even more exciting device. So how do we interact with the device? How do we use it actually as a user? So we have something which is called GGV input paradigm, which GGV stands for gaze, gesture, and voice. So basically gaze is some kind of a laser that comes from our eyes, I would say, or the forehead. So whenever we look at, we have a cursor that follows our gaze, I would say, but it's not like it doesn't follow our eyes, it follows our head movement, I would say. So that's the most important input mechanism. So whenever we want to interact with something, we have to first look at it. It's like in real life, basically. And the other thing are gestures. So this is the secondary input mechanism. So whenever we look at something, then we can interact with it. And we can interact with it by using gestures, for example. And there are basically two gestures for HoloLens. The first one is the bloom gesture, which basically is for a system level gesture. It looks like this. And it's for closing applications or firing up the start menu. And the other gesture is an air tap gesture. It's basically like catching a fly, for example. And it's the main kind of click thing, right? So the basic interaction looks like we look at something and we click it. But we don't have to click on it. We have something which is called like a gesture frame. We can't see it, but it's like an invisible gesture frame. So we can basically have our hand here and just look at something and click like that. And that's it. I mean, those are only two gestures, and the one available for developers is only the AirTap one. And the common question also here is if we can have like custom gestures. We can't. But based on this AirTap gesture, there are also some more gestures, but only based on this one. It's like hold gestures, which is basically half of the AirTap, and putting our fingers together. And based on this one is the manipulation and navigation gestures, basically the ones like hold one and then like a hand movement, and there we can track the movement of our hand. But it's not like super accurate, I would say. The other cool thing in HoloLens is spatial sound. So it has implemented something which is called HTRF, which stands for Head Transfer Related Function. It's a fancy name, but it basically mimics how it basically tricks our mind to thinking that objects are in the 3D space around us. So basically our brains and the hearing mechanism works like this. Whenever you're on the street, for example, and you would close your eyes and there would be a car driving down the road, you will probably know which direction and from where this car is driving, because the sound that comes to our ears is different in one ear and the other, and then our brain get to know where is the car. So basically those speakers in HoloLens works it's the same way. They trick our brain, and we really think while using it where the objects are in our world. And that gives a very good immersion effect for the user. Also, with this mechanism, it's, for example, we can occlude sound. So, for example, when we can program holograms whenever they are, for example, behind the wall can occlude the sound as well. So it also adds up to whole immersion effect as well. The other thing, and the coolest one in my opinion, is spatial mapping. You can see it here in some form, so it's basically a bunch of triangles. But as I mentioned with when I was explaining the sensor, the HoloLens, from the very beginning, when you turn it on, it starts scanning the user environment. And it does it constantly. Whenever it turns on, it's turned on, it scans the environment. It doesn't even have to have an app running. Whenever there is just an operating system running on it, it scans the environment constantly. So if I would have, because I have the device with me, if I would just turn it on and just walk with it like this, it will just scan everything that is here. And that's awesome, and a little bit scary, of course. But it gathers the information and it puts it on the operation system level. And as developers, we get access to that in some form, like using the API. And based on that, as you might expect, we can, in our applications, we can build the user location out of those data. So basically, we can have a model of our location, of user location, inside our application, which is cool. For example, we can visualize it with this nice white mesh, which means nothing. But what's cooler than that is that inside our game engine or the graphic engine that we use, in this case it's Unity, we get all the colliders, which basically colliders are for detecting like the physical interaction with 3D objects. So basically, wherever we have a real surface in our real world, we have nicely laid colliders everywhere. So whenever there is a floor, there's a nice collider there. So you might expect what that means. Whenever we have a 3D object in our application and, for example, we drop it on the floor, it will stay on the floor. And as the colliders are invisible, we will think that the actual 3D ball in our application lays on the real floor. And that's absolutely amazing. And that's what spatial mapping is. So, for example, to visualize it, we could have our room scanned and our mesh, as it was visualized before with white mesh. Here it's visualized with this green, nicely textured mesh. We can visualize it to show the user, for example, what is being scanned or not. But after we turn the mesh off and we just leave the objects, our rendered objects on the scene, we get something like this. So we basically think that those 3D holograms are out there and they are laying on the table and something's on our sofa, which is totally amazing. And that unlocks all the fancy scenarios. So basically, that unlocks navigation, for example, for our holograms, where, for example, our little agents in our games can run on our floor and they can omit obstacles, like real obstacles. So, for example, we can have like an AI which runs on our floor and omitting our chairs, for example, like real people do. We can have placement visualization. So, for example, we can lay some kind of glows or shadows on real surfaces, which adds up to the total immersion effect, for example. We can have physics interaction, so all the bouncing balls on the floor, for example. We would think that the floor actually interact with, the ball actually interact with the floor. And the cool thing is also that we can have an occlusion effect, so the digital content can occlude real things, and real things can occlude digital content. So, for example, if we would have one of those like behind the table would actually occlude it. So we would actually think that this thing is just behind the table. That's really, really awesome. There's one downside to the device and the technology that is there. It's namely field of view. So you might think that after seeing all the videos on the internet that we see holograms everywhere, like where our field of view is, we can see holograms. And the HoloLens itself looked like this, so that we can think that the screen is all over our face and we can see holograms like Iron Man can in his suit. But it's not like that. The technology that is being used in those optical fancy lenses inside doesn't allow actually for bigger, for larger field of view, and it's kind of limitation of the technology. I'm not going to go there here into details, but it of course might change in the future. Right now it's probably some kind of compromise between price, battery life, technology, I don't know. It's still, I mean, the device is still pretty expensive because it's $3,000. So I can think that they make some trade-offs there, probably. And so basically the field of view is something around 35 degrees. So it's kind of a letterbox inside, in front of us. So we can see everything around, but the holograms are being rendered only inside this frame. It's okay-ish. I mean, sometimes it can, well, it's the first thing usual users see when they, for the first time, use HoloLenses. It's like, oh, this is disappointment. But after longer use, you get used to that. And when the application is actually designed in a way that it follows some guidelines that allows to render only stuff like within this field of view or something like that, or giving some visual cues so that whenever something is outside of this field of view, the user can easily find it, like audio cues or visual cues, then it's okay. And I find it really not that bad thing. Tools. As programmers, you probably might be wondering what kind of tools do we use for developing. So the good thing is that those are well-known tools. It's nothing really fancy. So basically, Unity, it's a cross-platform game engine, graphic engine that comes with a really nice editor where you put up the scene and basically write some C# scripts, and then you're done, right? You can go a level deeper, I would say, and just use C++ with some DirectX, but what I mostly can see is that people are using Unity and C#. So all this technology that I just described unlocks all the new ways that we can interact with digital content in our life. And our lives probably and the ways we interact will change over time. So for example, we can have right now like a Nyan Cat running on your own desk, right? That's my desk, and I got my very own Nyan Cat running on it. It's very cool. And also, I don't know if you watched Power Rangers. There was Zordon, the mentor of Power Rangers, that was being displayed in this bluish cube, bluish thingy. I made my very own Zordon with my friend on a HoloLens hackathon once. So basically, we were scanning on the computer. We were scanning my friend's face with Kinect, and then we were sending it to HoloLens, and the user of HoloLens can have this Zordon talking to him from the top. That's really cool. But let's get more serious with that. As I mentioned, there are a lot of companies that actually embrace that technology, and they are actually building businesses out of it, and it actually happens. You might think that it's still a kind of a future. It's not. It's there. I know those people. I know those products, and they're actually there. And I'm actually talking with businesses that also want similar stuff. So let me just go through some of them to give you idea what it can do, and that it's really there. So I just listed here like 4 most common scenarios, I would say, and the ones that are popular on in the community, I would say. So the first one is from Citi. That's basically visualization of financial data. You might think that, well, who would need HoloLens in like financial world? But well, they did the app where they display basically all the financial trading stuff just in front of the user eyes. So instead of looking at monitors, we can have all those nice bubbles and graphs in front of us, and we can interact with that with gestures. That's kind of cool, right? And I don't know where it brings money, but it's cool, right? Anyway, the jokes aside, Ford recently announced that they're starting using HoloLenses for design purposes. So basically, right now they are enhancing the designing process with HoloLenses, where designers can see what they're actually designing. And here we can see like the cool scenario, which is actually possible, where we can program our application in a way that multiple users can wear HoloLenses and they can share this holographic world. So basically we can have two users here looking at the same model and they can interact with it. And well, that's pretty cool because we can do all sorts of collaboration stuff with it. And as I mentioned earlier, with those VR headsets from Microsoft, we could have like a third guy, for example, which would sit somewhere else in the office, and he or she could have this VR headset, and he could appear, for example, here as kind of an avatar for those guys, and the guy with VR headset would actually see them as avatars in the virtual world and the model in the virtual world, which is totally cool in my opinion. And you can see those kind of videos as well on the internet, and there are actually tutorials by Microsoft on how to do that. I've seen the tutorial with an island where one guy was wearing, I think, yeah, one guy was looking from outside on that island, and there was a little guy going on that island, and that guy was the guy with the VR headset playing that game. And the guy with the HoloLenses was kind of God, and he was looking like all over it at the game. It was like mind-blowing in my opinion. And the other scenario, it's kind of one of my favorites. It's the place where I focus on right now as well. It's by Schneider Electric, and it's an app for service workers, so basically maintenance for manufacturing, for example. So whenever we have like some piece of machinery, appliance, or something like that, industrial something, we can have an application that support maintenance process for it. So we can have a service worker that would basically wear the HoloLenses, and when he or she would approach this piece of machinery, there could be like a whole bunch of digital stuff laid on that machinery. Those can be, for example, like the workflow visualized on how to perform the task. It could be a checklist of stuff, what to do on this machinery to complete the task. It could actually show some kind of, for example, I don't know, arrows and point the screw, just unscrew this screw, for example, right? And this is really cool because there's a lot of maintenance work out there to do, and usually those people use like phones or instructions, and they have, for example, this phone, for example, in one hand, and here in case of HoloLenses, they are hands-free, so basically they can do work, and the digital content is right in front of their eyes. And the other maintenance scenario is from ThyssenKrupp. It's a company from Sweden, and they do elevators. And that scenario is also the maintenance one. So whenever the service worker approaches the elevator that he or she is going to do some work on, he or she can have all the contextual information just in front of his eyes. So for example, he can have like video tutorials on what to do, service manuals. He can have like an actual 3D model of the thingy that he's going to work on. So we can basically render anything we like to support the work of the worker. And basically, I found one video on the internet. It was like side-to-side comparison of assembling some kind of appliance, industrial appliance, and the other guy on the left was doing it in a standard way. So he had a manual on the table like next to him, and he was connecting something and then looking to the manual, and then connecting something and looking at the manual. And the other guy on the right side was doing the very same thing, but all the instructions were in front of his eyes, and there was time measured, and it was like the guy with smart glasses was doing like way faster than all the work. So that's the thingy, right? There are also, well, we can't see, for example, in those applications the use of this special mapping feature where we have like the environment of the user scanned. So there are also some applications that make use of the spatial mapping, and the most common ones are actually the games that were delivered along with the release of HoloLenses. One of it is Young Conquer, where we have this little guy running on our floor, jumping on our bed and tables and stuff, and we can really see that the game is really happening in our room, and this is really cool. The other game, my favorite actually, it's called Fragments, and it basically turns our room. Our room is first being scanned, and the room is being transformed into a crime scene, and we are a detective that tries to resolve this crime, and basically, we are looking for the clues inside of our room, which is totally awesome, because we have to walk around and just kneel down to see something, to grab something. There are some holographic people that appears in our room, and they can actually sit on our sofas or tables or chairs. This is really the best immersive effect I've ever experienced on HoloLenses. And the other game, it's Roboride. It's very cool as well. There is this alien invasion, and the aliens are drilling through your real walls and coming into your room, and you shoot them. And whenever you miss-shoot them, you make the holes in your walls. The immersion effect here is awesome as well. So I have HoloLenses with me, so we can try it out. Whoever would like to try it out after the session, I can show you. Yeah, but after this 1 year on the market of HoloLenses, there has been 300 plus apps released. I mean, those apps that went to Windows Store. So it might not be a lot, because if we would compare it to Google Play or what's it called, App Store, right? It's basically nothing, but the thing is that HoloLens, it's not a consumer product. It's basically, for example, it's right now targeted to companies right now, in enterprises. So there is not a lot of development into like regular, yes? Yeah? Oh yeah, so the scanning process, how detailed it is. So that's a very good question. It's really very common. Yeah, so the scanning, it's not for scanning detailed objects. So it's only for like detecting main bigger objects. It's not for scanning bottles, for example, and detecting if it's a bottle or not. It's not as detailed as that. So for this, you should use some other techniques, and there are some libraries for like image recognition or 3D objects recognition. One of those libraries is called Vuforia, and it works pretty well. You can first scan a 3D object, for example, and then program your application in a way that this object will be detected. So, for example, I scanned once my son's space shuttle, which is that big, for example, and then I programmed an application so that whenever I approach that space shuttle, I detected it, and you get like a coordinate system right in front of that object, and then you can build up on that object. So, but the spatial mapping thing is only for like environmental stuff. Yeah, I hope that answers. Yeah, it's not that detailed. No, not at all. So let's go back to the application thing. And what I was saying, yes, so it's mainly for enterprise stuff. So the majority of development, I would say, happens in the enterprise world, and with all those custom applications that we saw before, like the maintenance ones. But there are some other ones, and those are basically by developers just to show up or just train, and that's why there are not many of them, because there are not many users of HoloLenses. You can't expect like having a kid having this device, so there are not a lot of, like, there's no Flappy Bird or how is it called, Angry Birds or something like that. So we can, for example, imagine pretty easily how the future might look, right? This is very, I would say, it's not very cool scenario how we could see it here. It comes from the hyper reality video, where the video shows how the world might look if we would do too much AR. and it shows the part of life of the women that wears some kind of lenses, and she has like holograms everywhere. Well, we are approaching, with technology, we are approaching those days that it will be possible, but it's up to us how we use it. But this video, I really recommend you, watching it. It's like 12 minutes, something like that. But it's basically, everything is enhanced with digital content. It's pretty awesome. But that can also shows us what kind of scenarios actually are, and they not will be, they are available right now. But it's kind of futuristic, this video, but when you get to know what technology is actually on the market, you can think that we are really, really close. So yeah, next thing. You might think I'm talking only on HoloLenses right now, and maybe I'm a Microsoft guy or something like that trying to sell you this product. But I would like to show you that there are some other cool devices out there as well. But I want to point out that there's basically no other device that has so much capabilities as HoloLens have. I mean, period. I mean, there is no competition for this device whatsoever with this kind of capabilities right now. But there are some other things that might be cooler in different scenarios for augmented reality. For example, one is Meta 2. It's very similar to HoloLens because it has optical see-through lenses. We can see that the real world, they are using slightly different technology there so that the field of view is bigger. I think they have something around 100 degrees, but it has this one little bastard here, which is called cable. And this is where all the magic happens, because we have to be connected to the computer. But well, it might be useful in some scenarios, but I can't imagine like a guy, service worker, walking on the factory floor with a PC on backpack or something like that. I mean, it depends on the scenario, of course. And this device, as far as I remember, they can detect our, like the whole bunch of gestures of our hands. So basically we can grab something and grab it with two hands and do stuff with the objects, which is also pretty cool. But well, that might be useful for different scenarios. Also, we have ARKit and ARCore. Those are basically all those new and fancy libraries for Google phones and iPhones. And well, they recently, they can support some cool AR development, but mainly, for example, with spatial mapping, they can basically only detect like a flat surface so that we can put something on. And still, we can only use it on our phones and tablets. So it's good for some scenarios. So for example, IKEA, they released their, I don't know, at least I've seen it in Poland. I don't know how is it in other countries, but I've seen the app where you can basically look at your place and through iPad, and then you can place like sofas and stuff in your home with that. So that might be helpful. I mean, that's cool in the scenarios where you would like to reach like a lot of people, because everyone has like Android or iPhone right now. So if we would release AR application that use one of those, we are basically reaching lots of people, right? So that's the thing. If we would release something for HoloLenses, we basically hit not that many people. There are also things like Google Glasses, Epson Move Area, and a whole bunch of others that I'm not going to mention here because there is no point of it. But those usually live only in the enterprise area. I mean, Google Glasses were released in 2013, and there was a lot of hype around it, and then the project was killed for some reason, because Google then realized that the consumer market is not ready for it. So they reactivated the project silently first, without, they partnered with other companies, like manufacturing companies, for example, and they silently were developing the second version, and after a while, well, I think this year, it was the beginning of this year or something like that, they announced that Google Glass is still alive, but it's called right now not Explorer Edition, but Enterprise Edition. So basically, you can develop for this device. It has less capabilities than HoloLenses, of course. Well, we can see the size, so there's no computer here and there's no cable. So basically, in Google Glasses, I don't know how many people have seen it, or how many people had it on your eyes, or one person. So I will explain. So basically, this one optical thingy in front of one eye, and there we can display some digital content, but basically this content just follow the user. It's like in front of your eyes, so it works basically like heads-up display, right? It doesn't blend with the environment at all. But it's very helpful in some scenarios. We have also camera here and stuff. So for example, when I'm talking with different businesses, some of them are like, well, we do not need HoloLenses because it's like, it does too much. We would like to have this because it's smaller and it does what we want it to do. Just, for example, just display the steps for the user in front of the eyes, and that's it, or simple instructions. So it's useful in some scenarios, of course. And Epson Move Area is very similar to what Google Glasses does, but it has like both eyes and stuff. And well, that's pretty much it. And now it's time for question and answers, and time for whoever would like to use HoloLenses and see and would like me to explain anything more. Feel welcome to approach me, and I'm here all day, so thank you. And questions? Thank you. Questions? Oh no, I wouldn't use it for sport. No, it's too bulky. No. Actually, for sports, I wasn't mentioning here, but I don't remember the brand, but there are some brands that are actually developing smart glasses for sportsmen, like for bike riders and runners. So those things are out there, and those are like very specialized glasses for those kind of activities. Yeah. Something else? Oh, so the question is if we can use some other language than C#, right? Yeah, because the Vox is usually a Java conference, right? Is that true? Yeah, so C# is kind of, but it's very similar to Java, actually. It's not that bad. Or shouldn't I say that? Well, we can use JavaScript, I think, and with Unity, and we can use C++ if we would be using DirectX. But that's pretty much it as far as I know. Yeah, I think that's the answer. I haven't seen any other languages. Yeah. I'm from the .NET world, so C# was more than enough for me. Any other questions? Yes? How complex it is to typical development? Oh, well, probably it depends on the developer's background, right? I mean, for me, for example, I was like a web guy, and I was doing mobile stuff. So when I switched to AR stuff, it's like, it's totally new world because it's basically like game development. You deal with all the vectors and matrices and game loop and all the frame rates, and you have to write scripts where basically no rules that you know from enterprise development applied, where, for example, you use public fields on your classes and all that kind of stuff. So it's like, for me, it was like a totally new world because I was coming from different background. So yeah, for a web guy, that would be some kind of a hard way to get there, but it's not that hard. I mean, Unity is a very nice game engine that basically you can do lots of stuff just by putting stuff on the scene, just clicking for it. So it's not that hard. I started this year, and it's like I'm now able to create something. Yeah, I mean it can go difficult if you're not a graphic designer. I mean 3D graphic designer, where you start dealing with textures, lighting, shaders, and all that stuff. And that's totally, I mean that's a totally different profession, I'd say. Oh yes, yeah, absolutely. It's like you would be writing a game. It's basically the same. So imagine like any 3D game on your computer. It's basically the same rules. Yeah. But here you're dealing with like, you don't have like a GeForce 1080 here. You have like a slightly the worst device, right? So we have to make sure that the frame rate is okay. The frame rate has to be like 60 FPS. So yeah, it can get tricky. You have to learn a lot if you're a web guy, yeah. Any other question? When we deploy? No, we don't have to connect. It's a computer by itself, so it's a PC basically on your head. Yeah, so that's the cool thing. I mean, there is one scenario, for example, where you would like to get some rendering on your PC because you have, for example, like very complex models. So there is a possibility actually to render stuff on your PC and then transfer it to HoloLens for it to display it, and that's a cool scenario as well. But you get the latency at like 20 milliseconds or something like that. So that's not for like very fast environments or some shooting or gaming, but if you have like static big models, then you can render on the computer and then transfer it to HoloLens, and it's by Wi-Fi. But most scenarios are like everything happens here. Yeah. No, it's not. No, it's not. No. It's, in my opinion, for now, it's enough. It's okay. All the solutions I've seen are really good. Yeah.